When we think about our sensory experience of the world, the brain is the supercomputer behind it. The heap of tissue sitting in darkness inside our skull never experiences the world that we do, yet is the machine behind it. Our sensory organs collect the information which is sent up to the brain for processing, where a world of energy and matter is transformed into the reality we experience. We could almost think of these sensory organs as attachments or accessories that merely collect the information for the brain to create this world. From birth, we are creating and strengthening our neural pathways. These are the connections between nerve cells that are excited or activated by the information collected by our sensory organs. Simple examples could include the smell of bacon or the sight of the colour blue. A unique feature of the human brain is its ability to adjust and rewire these neural pathways, and this is known as neuroplasticity. The brain is constantly making new connections and strengthening existing ones. A major function of neuroplasticity is axonal sprouting. So undamaged axons sprout new nerve endings and form new connections. Each sensory organ enables each sense, as we've discussed. Therefore, if one of these attachments is faulty or doesn't work, the sense is disabled, and new neural pathways must be created or existing pathways consolidated. This is why a blind person might experience heightened senses, such as hearing or taste. And the diagram behind me compares the activity of a deaf signer's perception, seeing Braille, and a hearing speaker listening to English. So as you can see here, the brain of the deaf subject has obviously adapted and rewired itself to access the same information, which is language. So these different parts are highlighted as the brain has rewired and caused new connections. Okay, so we've heard of cochlear and retinal implants, and what these do is provide the necessary information that the eyes and the ears used to before they stopped working or became faulty. So the retinal implant, for example, collects visual information, transmits it into digital information, which sends it down the optic nerve as electrical information. So the information is in the same form, but comes from a different source. So the brain, it kind of sees this as a new language at first. It's the same information, but it's in a different language, it's in a different form. But as it has the ability to rewire itself, it can kind of constantly make new connections, and it gets to understand this language and this new information. So this poses the question, and many questions. What if we could, say, see through our tongue? And this is exactly what the BrainPort does. So a blind patient will wear this grid on their tongue. They have glasses with a camera mounted in between, and what it does is it converts digital pixels into electrical impulses, which are sent as bursts from this grid onto the tongue. So the information would usually travel down the optic nerve from a seeing person, but the brain will take in whatever data it gets, which is in the same form as it's come from visual information, and then it figures out how to use it. So it starts to understand this language. And this works. So mountain climbers have seen to use this. They see the hold, they get spatial awareness, and this is because the brain is actually learning to use this information. Another example is the VEST, also known as the variable extrasensory transducer. So as you can see here, it's a vest that a deaf person wears, and it's covered with tiny vibratory motors that convert data streams into dynamic patterns of vibration across the torso. So basically it gives hearing to the deaf. So digital pulses of sound are sent as electrical impulses into the torso. And as it's the same information that the ear would usually get, the brain senses that and then adapts and rewires itself. And this is also working as well. And this brings up so many questions about the future, such as what if we could control machinery or a vacuum with our mind? What if we could perhaps hear temperature? What if we could access our emails and data streams in the cloud from our brain, for ourselves, which is extremely interesting. And yeah, thank you for listening.